Hello everyone, welcome back to my LeetCode journey. Today we are solving LeetCode problem 35, search insert position. The problem is a great introduction to binary search, one of the most important algorithms in coding interviews. Let's get started. So what the problem says is, given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O log n runtime complexity. What the problem says is basically we can get that in example 1356 and the target is 5. It says there nums of array of nums is given as 1356 and the target is 5, which means 5 is the target, and it asks if 5 would be there. If 5 is not there, I'm sorry. It says if 5 is there, then return its index. And if it is not there, then return the index where it should have been. Like in this condition, in this case, 2 is target and 2 is not in the array. But we got an output 1. Output is 1 is 1th index. 0 is 1 and 1th index would be 2. 2 would have been there and the 1th index. So similarly, it goes through this. And simplest idea is linear search. Linear search is okay, but it would be a little not so good, because why linear search would not go through this? Because it has already given that the algorithm should be in log n. So we will go through binary search. Linear search problem is target equals current element, return index, target smaller than current, return current. Basically, in linear search, it would not be fast enough. So we will go through binary search. In binary search, instead of checking every element, we first divide the array into two, first half and second half, and we maintain low, high, and mid. Mid would be low plus high minus low by 2. And if target is equals to middle element, then we will return the mid. And if target is larger than the middle element, then we will search the right half. And if target is smaller than the middle element, then we will search the left half. Okay. That's what. Then let's go through the code with binary search. So let's go int. In here we will first maintain low 0, then int high is equal to nums dot size minus 1. Minus 1 cause well, when iterating nums dot size would give out of bounds error. Okay, so with starting with a while loop, while low is less than is equal to high. Why so? Cause low should always be less than high. When low and high is equal, gets low is low gets greater than high, then that's problem. Simply if here int mid is equal to low plus high minus low by 2. What is mid? Mid is basically low plus high minus low by 2. Why we are directly not doing high, because it may sometimes not consider all the problem, all the circumstances. So to basically check for every edge case, we are doing high plus low, high minus low by 2. Okay, so there goes the condition. If nums of mid is equal to target, then return mid. And if it does not, so then we will have a else, not simple else, but a else if nums of mid is less than the target, just a minute, less than the target, then the low will be mid plus 1. So what we are doing here is, when the mid is less than the target, which means target mid is already less than the target, then the target would be there in the lower end. So yeah, we will change the lower part. So in if that condition also not satisfied, then the last else high. High is mid minus 1, and then that's it. Return low. Let's run this code. Bit goes to okay, yes, submit. Okay, here we are. What is happening here? Why we directly returned low is because uh, we are most of the time, the if the value is there, then we will match the mid one, and if not mid, then it would be low. Why we are not going for high is cause high may have problems, cause what is the size of the array or whatever it can be, the problem with the high. And why we are, and the main purpose of returning low is the point where the number should have been present. If the number is not present at the mid, then the low is the point where the number should have been present. That is why we are returning low. Simple, if target is found, return immediately. Otherwise, move left or move right depending on comparison. If the loop ends without finding the target, low becomes the correct insertion point. So time complexity is O of log n and space is O of 1. That's how we solve LeetCode problem 28. Search insert position through binary search. The new topic which we went through today was the most important binary search. And here we go. Thank you. Thank